It's another learning episode. Again, this is your teacher, Marlene Nuno, and I'm going to discuss now about the triangle similarity theorems. For our episode, this is indicated in our most essential learning competency number 37, which is to prove the condition for similarity of triangles, such as the SAS Similarity Theorem, the SSS Similarity Theorem. Let us start. So to start our discussion, let me give you about the Basic Proportionality Theorem, which states that if a line segment intersects two sides of a triangle and is parallel to the third side, then it divides the two sides of the triangle proportionally. Let us look at this illustration. Let us name our triangle as A, B, C. And we have to draw a line segment, and let us name this as segment DE, where the segment DE intersects the side AB and side AC. And this segment also is parallel to our side BC. So at this point, there are three possibilities, of course. First, the segment AB is to DB and is equal to AE is to EC. So at this point, this is proportion to a small part to another part. Another is the proportion from one part to the whole, such as AB is to the whole segment AB and is equal to the right side AE is to the whole segment AC. At the same time, the third one is pertaining to other part to the whole segment. So we have DB is to the whole segment AB and is equal to the part AC to the whole segment AC. So these are the three possibilities in our proportion. Now let us see the application of this basic proportionality theorem. Let us look at this figure. We have triangle PRT. Then we have segment QS, where this segment QS divides our side PR and side PT. And this QS is also parallel to our side RT. So if PS is equal to X, as indicated in our figure, we have to find the length of X. So let us use our proportion. PS is to ST is equal to PQ is to QR. So meaning, we use the first one, which is part by part. Let us do the substitution. PS is represented as X, ST is 8 centimeters, where PQ is 4 centimeters, and QR is 16 centimeters. Then, if we're going to do the cross multiplication, X times 16 is 16X, and 4 times 8 is 32. Dividing both sides by 16, we will get X is 2 centimeters. So let us do the checking first by substituting 2 in terms of X. So we will get 2 to 8 is equal to 4 to 16. If we're going to simplify this, we will arrive at 1 to 4 is equal to 1 to 4. So therefore, our answer X is equal to 2 centimeters is correct. Now let us have another example. This is our figure, and in triangle XWZ, YV is parallel to ZW. and XW is equal to 25 millimeters. XV is equal to 15 millimeters and YZ is equal to 16 millimeters. So what is the length of XY? So at this point, we're going to use the proportion XV is to XW is equal to XY is to XZ. So we use the second one, which is 1/4 to the whole. Then by substitution, XV is 15 millimeters, XW is 25, then XY is our unknown, wherein XZ, so in the figure, we are going to add the length of XY to 16 millimeters. Then simplifying by cross multiplication, we have 25 times XY is equal to 15 times XY plus 16. Let us have the multiplication. So we have 25XY is equal to distributive property. 15 times XY is 15XY and 15 times 16 is 240. Then, to combine similar terms, let us apply the addition property of equality. So 25XY less 15XY is equal to 240. Wherein 25XY minus 15XY is 10XY. Then dividing both sides by 10 so that we will get XY is equal to 24. Let us do the checking. So we have 15 to 25 is equal to, let us substitute the value of XY, which is 24, is to 24 plus 16. Let us simplify 24 plus 16, which is now 40. Then if we're going to simplify to its lowest form, we will get 3 to 5 is equal to 3 to 5. So they are now proportion. Now let us proceed to the second one, which is the AAA Similarity Theorem, which states that if the corresponding angles of two triangles are congruent, then these triangles are similar. So in the figure, we have triangle MNP. That is corresponds to triangle XYZ. Then, given that angle M is congruent to angle X, angle N is congruent to angle Y, and angle P is congruent to angle Z. But let us have first to prove that these triangles are similar. Now let us have our proof by indicating our statements and reasons. Let us construct segment AB such that segment AN is congruent to segment XY and segment NB is congruent to segment YZ. That is by constructions. So angle N is congruent to angle Y, that is indicated in our given. Then we can say that triangle ANB is congruent to triangle XYZ. These are by side angle side congruence. Then angle NAB is congruent to angle X, and angle NBA is congruent to angle C because the corresponding parts of congruent triangles are congruent. Then angle M is congruent to angle X, that is also indicated in the given. Then angle NAB is congruent to angle M, angle NBA is congruent to angle P. By transitive property using statements numbers 4 and 5. Then the measure of angle M and P is equal to the measure of angle A and B by reflexive property. Then angle MNP is congruent to angle A and B because of the definition of the congruent angles. Now segment AB is parallel to segment MP. The reason is that if two lines are cut by transversal, the corresponding angles are congruent and the two lines are parallel. So we can say that segment NA is to NM and is equal to NP is to NP using the Basic Proportionality Theorem. So NA is equal to XY, the same with NB is equal to YZ because these are the congruent segments have equal measures. So triangle A and B is similar to triangle MNP by definition of similar triangles. Therefore, triangle MNP is similar to triangle XYZ by transitive property using statements 8 and 12. Now let us proceed to side-angle-side similarity theorem, which states that if an angle of one triangle is congruent to an angle of another triangle, and if the lengths of the sides, including these angles, are proportional, then the triangles are similar. Let us have the illustration. So in the figure, we observe that angle AEB and angle CED are vertical angles, and we all know that vertical angles are congruent. So if there are corresponding sides such as AE is to DE and that is equal to BE is to CE. Therefore, we can say that triangle AEB is similar to triangle CED by SAS Similarity Theorem. Now let us have the proof. So we have this illustration. Our given is triangle XYZ that corresponds to triangle ABC, where our angle Y is congruent to angle B. And we have YZ is to BA is equal to YZ is to BC. So these are the corresponding sides. Then, we have to prove that triangle XYZ is similar to triangle ABC. Let us have our proof. Again, we have here our statements and reasons. So we have to draw segment MN such that segment BM is congruent to segment YX and segment BN is congruent to segment YZ. That is by construction. So we have angle Y is congruent to angle B. That is indicated in the given. Now, this triangle XYZ is congruent to triangle MBN. That is by SAS congruence. Then we can say that YX is to BA is equal to YZ is to BC. That is given. We have BM is to BA is equal to BN is to BC. That is by substitution using statements 1 and 3. Then MN is parallel to AC. That is the converse basic proportionality theorem. So angle BMN is congruent to angle BAC and angle BNM is congruent to angle BCA. Reason is that if two parallel lines are cut by the transversal, the corresponding angles are congruent. Then angle B is congruent to angle B, of course, that is reflexive property. So triangle ABC is similar to triangle MBN. That is by AAA Similarity Theorem. Therefore, triangle XYZ is similar to triangle ABC. The transitive property using statements numbers 3 and 9. Now let us have our SSS Similarity Theorem, which states that if the three corresponding sides of two triangles are proportional, then the two triangles are similar. Let us look at these figures. Comparing the triangles MPN and triangle QSR. So with respect to their sides, MN measures 10 while QR measures 5. So if these two are the corresponding sides, then the ratio between them is 10 to 5. Or we can simplify this to 2 to 1. Similarly, with our MP, which measures 8 units, then the corresponding side is QS with 4 units. So the ratio between the sides are 8 to 4. So to be simplified also to 2 to 1. At the same time, we have the side NP, which has 6 as the length. Then it corresponds to side RS with 3 units length. So the ratio between them is 6 to 3. So therefore, that is also simplified to 2 to 1. So if we have similar scale factor of 2 to 1, the two triangles are similar because that is also indicated in our SSS Similarity Theorem. But let us have a further proving. Let us have our formal proof of this theorem. So in the given, our triangle ARM corresponds to triangle LEG, such that their sides are proportional. AR to LE is equal to RM to EG and is equal to AM to LG. So we have to prove that triangle ARM is similar to triangle LEG. So let us draw segment XY such that segment XE is congruent to segment AR and segment EY is congruent to segment RM. That is by construction. Then, segment XE is equal to segment AR and segment EY is equal to segment RM because the congruent segments have equal measures. So we have the proportion AR to LE is equal to RM to EG is equal to AM to LG. That is indicated in our given. So we can say that XE is to LE is equal to EY to EG by substitution using statements 2 and 3. Then angle E is congruent to angle E itself, of course. That is by reflexive property. Therefore, we can say now that triangle LEG is similar to triangle XEY by SAS Similarity Theorem. So to continue, we will arrive at proportion XY to LG is equal to XE to LE because that that is through the definition of similar triangles. Then, xy to LG is equal to AR to LE. By substitution, that XE is equal to AR using statement 2. Then XY is equal to LG times AR to LE. Same with AM, which is equal to LG times AR to LE by multiplication property. So XY is equal to AM by transitive property using statements number 9. So we can say now that triangle ARM is congruent to triangle XEY by SSS congruence theorem. So triangle ARM is similar to triangle LEG using transitive property by using statements 6 and 11. Well, that's all for our lesson. I hope you learn and follow on how we prove similar triangles. Now, how well do you know? It's time for me to check. So how will you answer the question, is triangle ABC similar to triangle ABE? By looking now at this figure. Okay? So, that's all I can share. If you have some questions or clarification, let me know by writing your comment below. And please keep on watching my YouTube channel, Teacher Marlene Nuno, and do subscribe and hit the notification bell for the updates of my video. Thank you for watching. God bless everyone.